So Ellexus is the I/O profiling company. Some of you already know who we are, and hopefully you'll get an insight as to what we've been doing on ARM. For those of you who don't know who we are, I'm going to introduce the company and what we do. I'm going to talk about our journey migrating our tools to ARM, and I'm going to talk about some of the sort of case studies, sort of things that you can look for when you're doing the migration. We are the I/O profiling company. We mainly work in high-performance computing, but we're not the high-performance computing company. We work in any industry where big data meets big compute. Actually, we work in some industries where actually a small amount of data meets a small amount of compute, but they still care a lot about their dependencies and their I/O. So, and our customers, we're based in Cambridge, so I haven't had very far to come today. I appreciate a lot of you have made very long journeys to be here. Our customers are some based locally and some based around the world. So I realise I'm probably preaching to the converted here, but why should you care about I/O profiling? It used to be something that you didn't have to care about very much unless you perhaps were running very I/O-bound applications, but now it's something that everyone needs to care about. You can very easily overload shared storage. You can very easily ruin your application performance, not just when developing the application, but also when deploying it. You've got to think about I/O at every step of the way, from the algorithm level, from the architecture level, from the storage, from the system setup, from the way you deploy it. I'll go into a bit more detail later, but you can ruin the I/O performance simply in the way you've set up the arguments to your application. So it's very important to do I/O profiling at every step of the way when developing the application, deploying it, and running in full production. Why is it relevant for ARM? Well, ARM for many is a new platform. You'll be migrating applications to an environment where they haven't been run before. That's an area in which I/O issues can be exposed. I should probably explain actually what I mean by I/O. In our world, we generally look at I/O as being file system I/O or network I/O. We tend not to look at memory performance. That's something that you can get from other tools in the ecosystem that I'll talk about later as well. So when I say I/O, I mainly mean file system and network, mainly file system, but also things like database access, licensing access, object store and things like that. So it could be local storage, could be remote storage, but whatever happens, you've got to make sure that you use it appropriately. So this is an overview of what our products are. So I'm not going to go into too much detail today. We've only got a short amount of time, and if you want more information, you can always come and talk to me or talk to either of my colleagues here today, waving in the middle. Particularly Lewis, it's his second day, so ask him really hard questions. So Breeze is the first product that we ever launched, actually, and it's a tool for doing very detailed analysis of a single application. It's really what you start with when you're doing the migration. It tells you, as well as a lot of information you might need to debug any kind of deployment or recompilation issue. The most important thing it gives you is a list of every single file, every single program, every single library that your application has touched and how it used that data. So that means it makes it really easy to migrate with all the dependencies you need and really easy to debug any issues once you're there, because you can see exactly what kind of I/O patterns you're getting. Now, once you've got to the stage where you've got everything up and running, we also have tools for doing much, much more wide-scale profiling. This might be for running thousands of regression tests. It might even be for running in production on your system to make sure that any new I/O issues don't appear. So I'm going to steal John Master's line from this morning, which was he wants to make everything boring, and so do we. Mistral is about capturing the really exciting I/O patterns that you can do something about it, because boring means reliable, it means fast. So it's what we're all striving for. And finally, a lot of you in the room will be experts on IT, experts on what makes good and bad I/O, but your users might not be. Your users are experts in their own fields. So we've made Health Check as a tool that gives you a simple report that you can hand over to users, and it takes the hard work out of communicating a lot of the simpler kind of I/O issues, such as small reads and writes, such as files in the wrong place, that sort of thing. So with that tool set, I should explain, all of it runs at the application level, so really doing the migration should have been a simple matter of recompilation. We do have some assembly code in there as well, so that had to be rewritten. And we thought we'd start with a Raspberry Pi, partly because we had one, as you all do now, but also because I'm on the steering committee for the Raspberry Pi Foundation, and any excuse to do something with the Raspberry Pi is good in our book. And really, those of you who've worked really, really hard on the ecosystem will be glad to know it did answer the question, will it work on ARM? And that was a nice step to do to start with, but it didn't really save us any time because actually the migration was fairly straightforward. So if you have a Raspberry Pi, please go ahead and use it, but you don't have to. It's not a critical step. So step one was really just to cross-compile and migrate. We've already heard how the cross-compilation tools are now part of GCC. We were recommended that we use any version after 6, and we use version 6.3. And as I say, we had a bit of fiddling to get it going in our build, but those are really peculiarities to our application because we've got inline assembly in our applications for doing very specific performance analysis. Most applications won't have to work with that. And we work with the glibc, and of course it was a new version of glibc that we had to use. But again, unless you're doing very complex profiling things as we are, you probably won't have any of those issues. And once we got to that point, it was pretty easy because we work in the field of dependencies. We've profiled our own tools before, and so we know exactly what we need to move. Now, that's not necessarily the case when you're moving perhaps a third-party application or a legacy application. And so for that, you can use the Breeze products that I already mentioned. So because it detects all your application dependencies, it won't do the migration for you automatically. You're still going to have to do the recompilation, but it'll help you understand your build, help you understand what it's bringing in. Even before we started supporting ARM, we had customers debugging builds with Breeze because they couldn't understand where their error came from, didn't make any sense. They profiled it with Breeze and find they were picking up 3 different versions of GCC and combining them into a single application. So it's things like that make it really easy to pick up. And of course, you can do a kind of before and after to make sure that the application's running in the same way. You've got all the same config files and things like that. So the next step was to run on an actual real ARM server. So we used Packet.net, but they're not the only people with cloud-hosted machines. We chose a Cavium Thunder X because that's what they had. And then you get choices. You get to choose the operating system. You get to choose the location. I think they've added some locations. I think our engineers, they picked Ubuntu because the engineer who was doing this, that was his favorite. But we did testing across all of them in the end. And basically, it was so easy to get going that by the time we migrated to the server, our bill at the end of the month was less than the cost of a Raspberry Pi. So I think that is the measure of success. Obviously, we've done a bit more testing, a bit more in-depth migration since then. So we have spent more money, but the initial getting it up and running, we're happy with it. Was super easy. I really recommend giving this a go. If you don't have an ARM server ready, you can very, very cheaply get going with the applications before then. So now we've done the migration, I said I'd talk about some of the kind of case studies that you want to watch out for. This is really a kind of a list of gotchas. It's by no means complete, but it gives you some idea of the sort of things that can catch you out. The one at the top, it's really quite a specific problem, but I've listed it because it catches pretty much everyone. We've yet to profile an application of any kind of scale that doesn't do 1 byte reads and writes to some extent. It's so easy to do just by including a library that has been based on legacy code. Back when reading and writing 1 byte at a time wasn't really a problem. People don't necessarily know it's there, and it's very easy for that to look like CPU-bound behavior because of the extra system overhead that introduces, as well as it being very, very, very suboptimal for any kind of shared file system. So even if you're using local file system, don't do that, basically. You can save yourself a hell of a lot of pain by optimizing your single byte reads and writes, which could just be as simple as changing to an updated library implementation. It's not necessarily going to be a complete rewrite. Other classic issues that we see are data being read or written in the wrong place, temporary files put in the wrong place, temporary files put on shared storage. That can really harm performance. Hard-coded dependencies. It's really easy when you're just hacking something up to stick it in your home directory and leave it there, and then before you know it, you've got an entire company with hundreds of engineers with a dependency on your own home directory. So we've seen that quite a lot. And again, missing libraries, really easy to do. So those are some of the issues that we've seen that can wreck performance. We recently profiled an application. This wasn't on ARM, but it would have the same effect. The tool in question ran for 12 hours, and it was spending an hour doing reads and seeks on dev null, because the application, although the reads and seeks were actually pretty efficient if it was real data, hadn't taken into account the fact that there were configurations that didn't require that data. It still tried to read it in. And finally, benchmarking. So the thing that you'll all want to do as soon as you get your new ARM system is to benchmark it in some way, whether you do official benchmarking or whether you just want to see how fast something is in a quite informal way. And I/O's got to be part of that. It's no good just looking at the end-to-end runtime, because you might have some kind of hidden I/O issue under the hood that makes a massive difference to the runtime and gives you quite inaccurate idea of what the CPU is actually doing, and isn't really a fair comparison. So until you're getting a fair comparison with reasonable I/O results in both runs, you don't really know what you're measuring, and that could be reads and writes, it could be metadata. Performance, we're discussing over lunch applications that do things like stat everything in your home directory. Of course, the amount of stuff in your home directory dramatically affects the performance of your application. So things like that are definitely to look for, because that is something that could easily be a difference on your new system. So that's, and benchmarking, that could be, obviously you just pick the tool that's appropriate for that scale. So finally, we wanted to talk about the performance ecosystem. Obviously, I/O profiling has got to be done in a wider context. It's a piece of the puzzle. You can do so. This is just a sort of a sample workflow that you might like to do. You can do the kind of one-off migration and performance kind of have I set it up right? Kind of check with Breeze. You can then use other tools to do other kind of performance profiling, such as a linear map. They've got APIs to allow you to import extra data, and so one of the things we're working on is getting the data from our tools available inside the linear tools, because that's something that really adds value, seeing everything side by side and getting a complete view. ARM is all about having a unified view of everything. And then finally, of course, you can integrate Mistral to really make your I/O really boring, to make sure that you're not introducing any new gotchas into the system. But this is just one sort of example workflow. It depends exactly what you're doing. You want to come up with a workflow that works for you. So yeah, in summary, so migrating for ARM is really easy. Probably preaching to the converted here, but please go out and evangelize. The ecosystem is there. We heard from so many different people today about the different things they're developing and the different tools they're supporting and about the different kind of performance metrics you can get. We're just one of the vendors that can help you do that. And basically, let's work together to make HPC really, really great using this platform. So thank you very much.
Thank you.